Hello, and welcome to part two of my lecture for chapter 7 of Murach's third edition MySQL book. Um, Part 1 had to do with the content of chapter 7 that was long standing. Okay. Uh, um, Part two has to do with the new content that's been added at the end of the chapter. Uh, these are features that are new to the Murach book. They're also new to MySQL in version 8, which again is not very old. It's within the last year or so. Okay, so the feature that we're going to deal with um, is called a CTE, Common Table Expression. And in the current semester of my class at the University of Illinois, I've put into my weekly schedule and a an optional reading from Wikipedia, which is the main entry for hierarchical and recursive queries in SQL. And that's what CTE's common table expressions are. So let's just go take a peek at that. Okay. And it turns out that these are newer SQL features. So it says, you know what? This is not CTEs. I think I'm going to add one for common table expressions as well. So let's go back to common table expressions. That has a main entry in its own right. Oh no, it's down here. So I'm sorry. A common table expression, or CTE in SQL, is a temporary named result set. Okay, so it's kind of interesting. Temporary named result set. Well, what's that like? Well, remember those inline views? Well, they were temporary result sets, weren't they? Were they named? No. In my lecture of part one, I said that these inline views were not named. We were able to refer to them by a table alias. And I mentioned in chapter 12 we were going to talk about named views. Well, it turns out that these CTEs, or common table expressions, are a kind of step in between those two. So they are named, but it's a name that's only recognized temporarily for the life of the query. Okay. Now, so we're going to discuss this feature. I want to point out that uh, at this point, common table expressions are supported by Teradata, DB2, Firebird, Microsoft SQL Server. You'll find a lot of information about this feature in the documentation and just web entries for Microsoft SQL Server, Oracle, PostgreSQL, etc., and MySQL since 8.0. So at this point, this is not part of the SQL standard, but as you can see, this is a feature that's headed for the standard. Okay, this is implemented in almost every significant product, some of it pretty recently, as with SQL. So this is an interesting feature that's going to be around, and again, it is probably going to be around within the SQL standard when they get around to putting it in. Okay, so let's have that be what we're going to refer to now. So here's the syntax of a common table expression, CTE, with we can have recursive. So there are recursive CTEs, and we're going to see that right after just the plain CTE. And it has a name. It's using CTE name one as subquery. Okay, we can have more than one of these. Okay, so these go before the select. Okay, so they're like a preamble to the select. Okay, and they're an alternative to subqueries that are embedded in the select. Instead of putting the subquery, embedding it into select, we use this name in the select itself. And again, this is a name that lives for the life of the SQL that we're inside. Okay, so let's look. So we say with summary, that's the name of this CTE. So use with to start the CTE, summary as the name of it, as, and then in parens, that same old query text that we're used to. Okay. Do we need a table alias? No, we don't need a table alias because this baby has a name, summary. Okay. And here we're doing kind of the same thing that we were doing before. So we're saying select vendor state vendor name, sum of invoice total from vendors join invoices, group by vendor state vendor name. So that's the first one that we're going to use in the main query. Now we have a second one. We have a comma, and here's the second one. It's called top in state. Okay, so select vendor state max of sum of invoices from a summary group by vendor state. Okay, now we're going to go into the main part of the query. So where's the select? Select summary vendor state, summary vendor name. So here we're using the CTA name, CTE name. I'm in Chicago. The CTA will have to come out all the time. Summary dot vendor state, summary dot vendor name, top in state dot sum of invoices from summary join top in state. Okay, so we're joining these two together on, and then we have the expression that's going to join them properly, order by summary vendor state. So we're using the CTE names as prefixes to disambiguate things. And then we get the list of vendor states, then the vendor name, and the sum of their invoices. And there are 10 rows. And if we go back a couple of slides, we're going to say that we did that before with subqueries. Okay? So CTEs and subqueries are alternatives for each other. Okay, CTEs are thought to be clearer, easier to read, easier to use. CTEs are a new feature. They're brand new to MySQL. They've been around in Microsoft SQL Server for a while. But as you could see from that Wikipedia article that we went to, they seem to be implemented everywhere, which means that they're headed for the standard. And it's only going to be we're going to see over time if people really prefer to use them over the traditional subquery where we would be using inline views. I think it's easier to read personally, and the fact is that I think that people like what they saw in early implementations of this. This is how we got the demand to move this feature in to the rest of the products, including MySQL. All right, so let's go on here. Okay, so now we're going to learn about this recursive thing. Okay, And it's pretty cool. It's very powerful. Um, for some people, it'll just be sort of intuitive how it works. For other people, maybe less so, maybe a little more mind bending. But what it does is it uses this CTE concept in a recursive way. Well, what do we mean by recursive? Well, recursive as in recursive programming. And in recursive programming, we have a function that calls itself, okay, which would seem like that might go on forever, but there's always what we call either the base case or the end case. There's always a way to recognize the end. Okay, so what's interesting, if you've had an experience with recursive programming, is that typically within the code for the function, we describe the end case or the base case, and then we describe all the processing for the other ones, and that's the processing that calls itself. So these things call themselves until they recognize the end case and they go, oh, all that silly calling myself stuff is over. I'm going to put an end to all this by giving the final answer. Okay, then we come to the end of this recursive chain. So what's this kind of good for? Well, this is good for hierarchical data. Okay, and one kind of classic example of hierarchical data uh, is where you have a table that has a relationship with itself, either a formal relationship or an ad hoc relationship. And the classic one of those that we talk about are employee tables. And here we are, we're at the employee table. Okay, so I'm finding that type a little small, so let's make it a little bit bigger. Okay, so we have this employee table here. Um, it has an employee ID, that's the primary key. We have a last name, a first name, their department number, and their manager ID. And the manager ID is a foreign key that points right around into the same table, and it gives the primary key for the manager's employee row. Okay? So we typically, in this hierarchical situation, expect only one row, only one person at the top in this sort of American hierarchical corporation. So Cindy Smith is the head of this organization. So her manager ID is null. Okay? Everybody else points to somebody. So we've got, for instance, Elmer Jones, his employee ID 2. His manager ID is 1. So he's a second level employee. And down here, Paolo Locario has the same thing, manager ID of 1. Okay, so this is hierarchical because there are people who report to Elmer and to Paolo, okay, and they're the people who have the manager ID of 2 or 9. So if you can look, Thomas Hardy has reports to 2, and Olivia Hernandez reports to 9. So they're on level 3 in the organization, and then we go on and on and on. Okay? So this is typical hierarchical data. What kind of other data is hierarchical? One very popular thing that you'll see is in manufacturing applications. We have this thing that's sometimes called a parts explosion. Sometimes it's called a bill of material processing. But it's we have at the very top we have a big product, a whole product, and then we say, well, what are the parts of that product? Okay, and what they do is they point to a list of subparts. Okay, and each of those is a part in their own right, and they point to a list of subparts. So at the very top, instead of being the manager, you've got the whole assembly. You've got the uh, easy bake oven. Okay, and then at the bottom, at the very bottom of this tree or root system, you've got you know the smallest discrete parts of the easy bake oven. Okay, and there are a number of other applications too. Okay, so in this case, we're going to show the employees and their managers. That's what we're going to explore. Okay, uh, so what we have here is a recursive CTE that returns hierarchical data. Okay, so um, So what we've got here is a combination of two things, and I was telling you about recursive programming in terms of procedural programming languages like Python and Java. Of course, they're object-oriented, but they do work procedurally, and their functions or their methods can call themselves. Okay. And in general, when you look in the function or the method, you'll find some code that says, here's what we're going to do for the end case, the one that's essentially all the way at the bottom or all the way at the top. Okay. Uh, and uh, and then alternatively, here's what we're going to do for all the other cases. And the code for the other cases is what has the recursion in it. Well, same deal here. Okay. So what we have is we have a non-recursive query. This is the one for the end case, okay? And then we have a union all with a recursive query. This is the code for every other case, okay? So how does that work? Well, what's the non-recursive case? This is what identifies the top employee. So the non-recursive case is at the top. It's what's her name? Cindy. It's Cindy Smith. Okay, so that's the code that identifies. Oh, I've gotten to Cindy Smith. All right, and then this query is going to apply to all of the other employees. Okay. And what's going to happen is that this query, uh, so the name, the CTE name is employees CTE, and you'll notice that the non-recursive part does not refer to that name, but interestingly enough, the recursive part does. Okay, because we're joining on employee manager ID equals employees CTE dot employee ID. Okay, and one of the things that we are returning, let's see, we're returning the name, which the employee name, which is a concat of the first name, a space, and the last name, and then we have a ranking, which shows which level of the hierarchy they're on. Okay, well, there's only one person on level one. That's Cindy Smith, or I know her name's Cindy. I think her last name is Smith. Then everybody else is further down the hierarchy, and you can find out how far down by taking um, the ranking for that employee and adding one. Okay, so this is a pretty complex code, but when we run it, we get uh, we get all the employee, all the employee IDs, all the employee names, and then their ranking. And you'll notice the only person on level 1 is Cindy Smith. Who's on level 2? Well, I mentioned them before, Elmer Jones and Paolo Locario. Who's on level 3? Well, we've got most people on level 3, then we've got just 2 people on level 4. Okay? So, you can look at this in a lot of different ways. You can look at this as kind of magical. All right. This is within the new content within the chapters, so we're going at it very cautiously. But eventually, I think one can understand this kind of recursive use of this. This actually was possible before CTEs, okay, and it was done with um, named views and cursors. So there was a way to do it before CTEs, but this is thought to be a very much easier way to solve the same problem. So these recursive CTEs are becoming a very popular way to explore data hierarchies that are implemented with tables that have relationships with themselves. Um, in this case, showing the relationship between the employee and their manager. And that's all I'm going to say about this, and that's the end of the chapter. Let's see. Yeah, that's slide 36 of 36. So I'm going to say bye until next time. Bye-bye.